just what is parametric equations from what you guys learned in pre-calc honors. So at the very top, and I'll zoom in over on this side, if you guys can, and if you don't want to write in that little space, that's fine too. I keep telling myself I'm gonna leave more room, but I'm just gonna squeeze in one graph of it and then talk to you guys briefly about how to graph. And it's just on the basic level of plotting points, and that's all it is. Okay, why do we study parametric equations? Parametric equations allow us to describe a situation in which we want to introduce a third parameter. In most cases, this third parameter is time. So for example, if I want to describe the motion of a ball, yeah, I see Don throwing a ball, it's parabolic in shape, then you have a horizontal displacement and a vertical displacement that could be possible from this. And if I wanted to describe what the horizontal displacement was after a fixed number of time, like after 2 seconds, then I can just work with x of t versus y of t describes the vertical position after a fixed number of minutes or seconds. So let's say that you guys had two, and we're gonna see how this is going to pertain to eventually how parametrics will be related to vectors, will be related to polar. They're all tied together. And I don't know if you guys got to that discussion in pre-calc honors, but let's say you guys were given two equations with respect to time. So we know it's parametric if we see x written as a function of time and y written as a function of time. Just a quick note, you are not expected to graph on the graphing calculator, know how to graph parametrically, meaning changing the mode. So if during the, and I have to warn you guys about this because this always happens every year, one person on the test will switch their mode. Do not switch modes on, you're always gonna be in function mode. So there is a mode in your calculator for parametric and polar. We're gonna remain in function mode. You can graph something parametrically to see what it looks like, but it's not required on the AP test. So let's say that we wanted to get an idea of what this means. And they define for you guys that they only want you guys to look at this curve with time fixed between 0 and 2 pi. Okay, we're gonna create a table of values. And I think I'm gonna create the table of values down below here. I don't know how I squeezed everything in. Okay, so instead of an XY table, you have time is going to be kind of the independent part, and X and Y are now dependent variables, and they're both dependent on Y. So let's start with 0. And then we'll do large values of pi, or of large jumps in the intervals just to kind of get a sense of what this looks like. But 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so to make this faster, so I want you guys to just get a visualization of this. Can I have you guys go ahead and start to plug in the values? And this is what you're going to do. If you need a sense of what the parametric equation looks like, you're going to take 0, plug it in for t, and t on this, and come up with what the coordinate points are. Just look up to verify if you need to. Just a quick note for this series chapter. On the quizzes, I mentioned it after the first quiz because some people did it on the first quiz and then other people did it on the second quiz. You are expected to simplify trig expressions. Like if you end up with the Taylor series and you have like cosine of 0, don't just leave cosine of 0. That's not considered algebraic. They do want you guys to simplify that out. So I think some of you guys just left your answers as like cosine of pi over 2 was in your Taylor series expression. So just keep that in mind. So please ask me questions as we go along, but this is what you guys did in pre-calc, right? Am I right, you guys? You just graphed a couple of parametric equations for the most part. This is what you do if you had to graph it, is just plug in points. If you did this on the calculator, by the way, and I'm not gonna show you guys because I don't want you to to have to worry about graphing parametrically. Maybe if I have time the next time, I'll just kind of walk you guys through really quickly, share my calculator screen, or maybe do it on a video. But if you guys were to input this into the calculator on parametric mode, what you'll see is this is an XY coordinate plane. So you're going to plot only these values over on the right, because that's an XY Cartesian coordinate plane. So go ahead and plot those points. Okay, you might be asking, well, what is the big difference between this and the Cartesian coordinate plane? So how do we incorporate the time aspect into it? Okay, so there is just like with vectors, when you have like a third parameter that you're introducing into the picture, this is what it looks like if we just consider X and Y coordinate planes. However, if we incorporate time into it, we want to consider that this is the first sorry, you guys can't see that. This is the first coordinate I plotted, then this, then this, then this, and then back to this. Okay, so to incorporate that, we just add in arrows into our pictures. So to tell that with time, it's going in a counterclockwise direction. Okay, so incorporate in the arrows, and that's the part that makes it parametric, is that you're adding in this third parameter of time, and that's our graph. We're gonna see, just quickly, let's see if anyone can do this. How is this the equation of a circle? Anyone have any ideas? And I don't know if you guys got that far. I know that this is what we're gonna move into eventually. How is this the equation of a circle that I have here? Any ideas? Okay, very nice. So someone said, if you do x squared plus y squared equals 1, you guys do get sine squared plus cosine squared equals 1. Very nice. That's Pythagorean identity. Very nice. And we're going to move into that. That's going to be something you memorize for the AP test. And that's going to be how we link some of the vector concepts with parametric. So down here, that's kind of like the extent of parametric equations as it pertains to pre-calc honors that we're expected to know. I'd like you guys to list, parametric is going to be a quick one, because the focus of it will be vectors when we get to vectors and how it deals with parametric equations. So here, if you guys can write the things that you do have to know on the AP test, is how to find the derivative. So derivatives of parametric. Polar and vector. I'm including polar and vector here just because those can be expressed as a function of a third parameter as well, polar with theta, vectors with time. Okay, and then the length in parametric form. Arc length, if you guys want to add the part arc length above here, which is a concept we've already studied, but just in terms of X and Y, we're just going to introduce it with the parameter of time into it. Okay, so to get us to get familiar with what the equation is, and down below there, I created a box to eventually have the formula for dy dx. So when we think of the derivative for parametric equations, we're going to think of it as dy dx. Okay, so if they say find the first derivative, you don't think dy dt, you don't think dx dt, you think dy dx. Okay, so somehow we have to incorporate a dy dx into our formula. So let me just kind of have you guys think about this algebraically. Okay, so if I had dy dt as differentials, okay, like think of dy as a variable, dt as a variable. On the right, you have a variable dy and a variable dx. What would you guys have to multiply this by in order for the equation to be equivalent? What would you guys have to multiply the equation by to get it to be equivalent? Okay, if we think purely as just variables, yes. Okay, we would need to cancel out the dx, that's on the bottom, and then divide it by dt. Okay, so that expression is equivalent. Now, what is the meaning behind this? Okay, so if I give you guys the derivative, I ask for dy dx, that means that I'm taking the derivative of y with respect to x. And if it's not in terms of x, it's implicit and I have to times by the derivative of, so like if I'm taking dy dx and the derivative, the original expression is not in terms of x, I have to apply implicit, and it's kind of like timesing by y prime, but in this case, timesing it by dx dt or x prime. Okay, so if I solve this for dy dx, which is the first derivative, then I get dy dt over dx dt. So that's what you guys are going to write as the formula you have to memorize for the first derivative in parametric form. So simple enough, to dy dt over dx dt. Okay, for the second derivative, okay, we're going to do something similar. So we think about it in terms of parametric equations. This time it's saying, you know, if we think about what the second derivative is, you guys would tell me, oh, just take the derivative of the first derivative. It's not as straightforward with parametric equations. If I write that, that's saying take the derivative of y prime. Picture y prime as dy dx. Take the derivative of dy dx with respect to x. And this is how we write with respect to x when we take it a second time. Okay, so because it's implicit, same thing applies. We have to times by dx dt. Okay, so in doing so, if you guys isolate dy prime, which is the derivative of the first derivative, you get dy prime over dt over dx dt. And let me explain what this is. Okay, so this is the derivative of the first derivative like you guys would normally do. But in parametric, you guys also have to divide by dx dt. Derivative of the first derivative, but also divide by dx dt. Okay, so most of the times, this is a problem for students to remember because we're so used to just taking the derivative as is that we forget to divide by dx dt. So I would say if you guys had a trick question in this chapter, this would probably be it. It's the second derivative in parametric form. So take the derivative like you normally do, but divide by dx dt. We're gonna go over a few problems so you guys can see what I mean by that. So go ahead and flip the page. I'm gonna apply these concepts. Give it a moment for you guys to make sure you have those equations down. So derivative of the first derivative, divide by dx dt. Okay, I think it was better this year, but there was a chapter test in first semester where some people were like, what on earth is that? So just again, if you didn't know that was that meant the second derivative, this is the second derivative. That's the notation for it. Okay, let's go ahead and if I can have you guys attempt dy dx, I think it's pretty easy to do. Just feel free to glance up if you need to. But if I copy down the formula from the other page, it's simply dy dt over dx dt. Anyone have any questions on what I did there? And then please feel free to type it into the chat if you didn't get that. But all you're doing is taking the derivative of y with respect to time over the derivative of x with respect to time. Okay, so in your notes for the second derivative, it says take the derivative of the first derivative, then divide by dx dt. So when I look at the first derivative, okay, what rule are you guys going to use to take the derivative of the first derivative? What rule applies here? Okay, good. Some of you guys are typing in quotient rule. That is correct. So just apply the derivative to the first derivative like you would normally. So I'm going to use the notation just so we get used to it. This is the second derivative. And then see if you guys remember low d high minus high d low. because of the implicit part, this is the part where we divide by dx dt. So you have the expression for dx dt already. So I'm going to circle that. Dx dt was 2t plus 1. So we're going to divide by 2t plus 1. If this is a free response, you guys don't have to simplify that, obviously. But if you were to simplify this, you would multiply out the top and then combine like terms and then bring the 2t plus 1 up as times by 1 over 2t plus 1. The expression that you guys would get if you were to simplify is 4 over 2t plus 1 cubed. Questions so far? Isn't this kind of a relief after the series stuff to just be going back to derivatives, huh? Okay, so example 2. This is a very common application of, and I didn't realize I put this example in there. So there's one video that I have you guys watch for homework on Friday. Feel free, and I'll make note of it in the agenda. Feel free to skip that video because I'm kind of going over it here and I think it's good enough as long as you guys remember the difference between tangent and normal lines. If you don't, if you want to watch it, feel free to. And then there's a discussion on vertical tangents as well, which is important for your chapter test. So you feel free to just try the problem and then see if you guys can come up with the same answers. Okay, so in this one, find the equation of line tangent to the curve at the point given by the, or defined by the given value of t. Can you guys write for this application, equation of a line tangent? The slope is like what you guys are used to when you didn't have parametric equations. So slope is simply dy dx. Okay, it's not dx dt, it's not dy dt, it's a combination of both. So slope is dy dx. So you need slope and you need, what else do you guys need? You need slope and you need for all equations of lines, you need slope and a coordinate point. So here, and I always get really disappointed when a kid skips this question because they can't figure out the coordinate points. Okay, this is a pre-calc topic. How do I get the coordinate point, you guys? It's not given to me. How do I get the coordinate point? Okay, good. Plug in -1. Okay, don't get stuck there on your next chapter test. That's the most frustrating thing for me to see. Plug the -1 in. Okay, so if you guys plug the -1 into x, you're going to get the x coordinate. So I guess you guys can write out in your notes, you need x of -1 and y of -1. That's going to be your coordinate point, which is equal to, when you plug -1 in, 5 for your x, and then 1 for your y. Okay, go on and you guys can do this. Go ahead and find dy dt over dx dt. Oh, and I also want to say another frustrating thing to see is seeing dx dt on top over dy dt. So just, I guess, memorize the equation or think of it as change in y over change in x. However you guys want to think of it to remember the formula so we don't miss these it will be your easier questions on the AP test that's C related topics. So I added an M in front of it just to denote that that's going to be my slope. And then your calculations will go through all of it. Simplify if you need to, or if you want to. You don't have to. Plug in the -1 at the end, and then see that you guys get the same answer of 1 as the slope. And then go on and plug everything else in, keeping it in point slope form on your tests. So y minus the y coordinate, not the x. So y minus 1 equals the slope of 1, x minus 1. So if you guys want to, if you're not going to watch the video on Friday on this, because I essentially went over an example, if they ask you guys for a line normal, how is that going to be different for a line normal? Oh, thank you. X minus 5. How would you guys answer the question differently for a line normal? Okay, so a normal line is perpendicular to, so very good. The slope changes and it's negative reciprocal or opposite reciprocal. Sorry, I ran out of room, but I think you guys know what I mean. Okay, so opposite reciprocal. And if this was a follow-up question, I would just make sure to use the same coordinate point, just use the opposite reciprocal of the slope. Okay, here's how it looks like on the AP test. This was the AP test I took, 1998. Oh my goodness, BC6. Okay, go ahead and read that, read the beginning of that question. Can you guys type into the chat, what are you missing this time? What are you missing from this, the parameters that are given at the start? What are you missing that you had in the previous problem examples? Okay, good. You have, yeah, you don't have an x equation and you don't have a y equation with respect to time. You have instead a y with respect to x. Okay, so I want you guys to write out, first, let's come up with this x of t. They're asking us to find what x of t is, given that you guys have dx dt equals -1, or not negative, 1 over square root of 2t plus 1. What do you guys do to this to come up with what x of t is equal to? Okay, I highlighted another important thing you were given. You were given dx dt, and you were given what we call an initial condition, right? So what we are going to do from here is, if I want x of t, I can integrate this because it's with respect to time anyway. So go ahead and integrate and see what you guys get. This is the equivalent if some of you guys prefer to write it as -1/2. And it's been a while, but can I do u sub in my head for this one? Can I do u sub in my head for this one? Okay, and I asked that question because sometimes we inadvertently use u sub when we're not supposed to be using u sub in our head. This one, yes, because, and that when I asked that question, it's mainly, is it linear inside? If it is, you guys can undo timesing by the constant. Okay, so let's see what we get. So when you guys do the u substitution in your head, you're adding 1, you get 1/2, and then you times by the reciprocal of 1/2 to get 2. What else must you guys multiply by? Okay, so you have to multiply by the derivative of what's in the reciprocal of the derivative of what's inside. So if you normally in a chain rule multiply by 2, you would multiply by positive 1/2. Okay, so that's your antiderivative. Notice that the 2 and the 1/2 cancels out. And remember that you have that plus c. Don't forget that plus c at the end. And so we got 2t plus 1 to the 1/2 plus c. This is what x of t is equal to. Go back and plug in the values that are provided for you guys. X is given to you guys as -4 when you plug in 0 for t. And I would just caution and plugging in 0, that 0 doesn't always eliminate everything. And like you guys can see here, you end up with a 1 on the right. So C is equal to -5. So answering that question for this one involves that you guys solved for what x of t was. So the final answer, 2t plus 1 to the 1/2 and then -5. Okay, so they've got a follow-up question now that asks for what dy dt is. At the very start, I think Matthew mentioned we don't have y as a function of t. So this poses a problem for us, right? So if we write down this formula of the derivative with respect to x, we know that it's dy dt over dx dt. Can we think of this as three variables? We think of it as dy dx. We think of it as dy dt. We think of it as dx dt. Okay, what do we have here? There's two things we have. Okay, for sure we have dx dt. Okay, so we can plug in what dx dt is, and then good. Someone made the leap to say we also have dy dx. Okay, so we have y as a function of x. We can certainly find dy dx by simply taking the derivative of that. So I'll write this out. Dy dx is equal to, in this case, 3x squared minus 3. If I read the question, it says, find dy dt in terms of t. So I'm going to keep going with this. I have dy dx, that's one of my unknowns. So 3x squared minus 3 is equal to, what I'm trying to solve for is dy dt. What I also have is dx dt, which is -1 over, sorry, I keep thinking that's a negative. It's just 1 over square root of 2t plus 1. Okay, so go ahead and isolate. When you guys go ahead and isolate this, you're going to end up with multiplying by 1 over 2 square root of 2t plus 1. So just be careful on that. When you multiply both sides by that, it's going to go in as the denominator on the other side. So when I isolate, I get dy dt. I'll just draw an arrow here. It's not equal. Dy dt is equal to 3x squared minus 3 over 1 over square root of 2t plus 1. So I multiplied by 1 over 2t plus 1 on both sides. Okay, now the next question is, when you guys do that, no, I totally made a mistake on that, didn't I? Okay, when you guys multiply both sides by it, I should not put it on the bottom. Okay, when you guys multiply both sides by 1 over 2t plus square root of 2t plus 1, this cancels this side out. And on this side, it's 1 over square root of 2t plus 1, which puts the 2t plus 1 on the square root of 2t plus 1 on the bottom. So my apologies. Can you guys read the question again and tell me what is, this is one of the things I know I wanted to get back to on review for the AP test, but reading the question carefully for when we were doing implicit and then doing an extra step here. So there was, going back to whatever test that was, maybe chapter 3 on the implicit differentiation, many of us read this 1-3 responses and saw it as like, this is it, this is my final answer. What's the problem with my answer as it's provided right now? Any ideas? Okay, so it's not in terms of t. So whenever it's not in terms of just a single variable, we're gonna look for clues from our given parameters for how do we get rid of that t. Okay, so obviously the x is gonna be the issue. So what am I going to substitute into that? So let's say you guys initially go back and you look at what's here. You don't have x of t here. Where do you have x of t? You have dx dt, and then someone said, look at the answer to A. The answer for A is x of t. Okay, so x of t is x. So we're going to go back now and then substitute that in. So 3, and then if it's saying x squared, so if I square, just make sure that it goes over the entire expression. So minus 5 included, and that's squared, minus 3, all over the square root of 2t plus 1. No need to simplify the expression. Okay, are we doing okay so far still? Okay, so just make sure you guys, with these parametric equations, read the directions. So I'm going to circle this part, speed of the particle. This is our last part, you guys. Okay, and then we're going to come back to this after we discuss vectors. We don't know how to answer that yet. Okay, find the location at time t equals 4, we can answer. Okay, find the location after time t equals 4. Okay, location is what your position is. So we want to know what x of 4 is and what y of 4 is. Okay, so in this case, x of 4, we have what x of 4 is by just simply plugging 4 into part A. So go ahead and calculate, what do you guys think x of 4 is equal to, and type it into the chat. And I want you guys to think about this next part without me telling you guys what to do for this. Okay, so very good for the -2. How would I possibly find out what y of 4 is equal to? So I had x. Okay, I had x. How do I figure out what y of 4 is equal to? Very nice, Matthew, that is correct. Okay, so there's 2 ways of thinking about this, and I want to say the first 2 people that answered are correct. Matthew, Brandon, you went in the right direction. And then the other way of answering it is how most of us will probably think of it. Okay, so I want to kind of have you guys stop and think about the 2 scenarios, because this is where we kind of get stuck sometimes. Okay, someone suggested maybe you integrate dy dt. Okay, so go back to dy dt. Does that look like something we want to integrate? No. Okay, so there's got to be another way. Yeah, that would be so much work. That is true. Okay, there's got to be another way. And I know 2 people has already gotten it, but I want to see if anyone else think of how else can we answer this? So many relationships here. Okay, so you have, yes, you have x of 4, you guys. X of 4 is -2. There was a relationship at the start of y in terms of x, right? So if I have what x is at that moment in time, I can take that value, plug it into this equation to come up with what y of 4 is equal to. So let me just see what the equation is. So I'm going to take -2, cube it, and then -3 times -2. So final answer for this, 8 plus 6, or -8 plus 6, -2.